So let's start with Sam. Sam, you're the founder of Mastra, the TypeScript agent framework. But you're also the author of Principles of Building AI Agents. So I think one thing that makes me curious is that as an expert in this field, why aren't you hoarding this knowledge for yourself and using it to beat the competition? What inspires you to share about your knowledge here?
I think we all kind of come here to learn from each other. And hopefully, I think books, principles, and then this one is patterns, and there's a few copies at the back if you haven't got yours yet, can contribute to that. Mastra is an open source framework, so if in general, learning about agents, workflows, RAG, memory, evals, tracing, et cetera, the next step is here's the code for how you can do it yourself. So I think it sort of helps everybody.
Cool. That's awesome. Thanks for that. Priyan is an AI engineer at Arize AI. And Priyan is the creator of prompt learning, which is a prompt optimization framework that achieved really impressive results recently, like 15% accuracy improvements on SweBench, the benchmark for agentic coding, like replacing a software engineer. Priyan, what's the experience of building out that prompt optimization framework? How has that changed your perspective on what it means to build AI today? Oh, sorry.
So I think the experience of building it, so I think the first step was kind of sort of like the motivation for prompt learning in general. So right now we have Observability, which is kind of giving you some insights into how your applications perform, how your agents perform. Then you have Evals, which is analyzing that data and giving you some some labels or some explanations into where your agent performs well, where it doesn't perform well, and sort of why. And that final step is kind of optimizing your agent based on that data, right? And so until now, that process has always been pretty manual, right? You look at your traces, which tells you for every single request, here's what my agent did. You have your evals, which tells you whether what it did was correct or not. But then actually making the changes to your agent is still a very manual process, right? You have to go into your code, edit your prompts, edit your tool calls, however you set up, maybe if you have some RAG, however you set that up. And so the motivation for prompt learning was to kind of automate that process in kind of the spirit of automation, or I guess kind of self-improving. And so the first step of that was kind of designing a very simple sort of kind of algorithm. It's a very simple algorithm. And then the next step was formalizing that into an SDK that people can use. And so, yeah, I think we're in a pretty good spot now, putting it into the product and everything. And so, yeah, it's been really fun.
Super cool. And Morgante, I was curious, I know from your background that, so currently Morgante, you're the head of AI at Honeycomb, but prior to this, you're the founder of Grit, which is one of the earlier AI coding startups, as well as leading really large initiatives to bring DevOps to Google Cloud customers. And so I guess across your experience at organizations of very different sizes and very different kinds of customers, what do you think are the things that are the most fundamental that don't change no matter what size of an organization you're at?
Yeah, I guess there's business principles and technical principles. On the business side, I think no matter whether it's Google or a one-person startup, which Grit was originally, just talking to users all the time. Literally, I had to directors at Google, VPs, and I was like, oh, you're wrong, because I talked to these 5 users at these huge customers that won so many arguments. And then similarly, startups, you have to be out there. On the technical side, you run into the same problems sort of fundamentally around networking and state. I think are sort of the 2 fundamental things to understand in any technical system, regardless of the size, to think about.
Cool. That's super cool. And we'll stay with you for the first question overall, and I think this is the super obvious question. We said this is a panel about AI observability, but actually haven't defined the term yet. So to you, what does AI observability mean?
It's a good question, because people at Honeycomb constantly actually are unsure. Even our own team sometimes, they're like, oh, you're head of AI, what AI observability are you doing? I think there's actually 2 really important things about AI observability. There's AI for observability and observability of AI. And at Honeycomb, we do both. I lead a lot of our efforts to do AI for observability. So we have a great feature that lets us do basically, chat with your observability data, right? If you had logs as sort of the most traditional kind of observability data out there, chatting with your logs is a form of that. Observability for AI, which I think is probably the more interesting topic for today, is about being able to look and see what your AI is doing in production, monitor it, understand it, and ideally learn from that behavior. And that's the goal of pretty much every observability product, but especially in AI.
Cool. That's super cool. Priyan, how about you?
Yeah, so I think observability as an umbrella term is just like insights or explanations into how your application performs. And there's software observability, which is kind of like checking whether the different components of your software performed well, right? So like, let's say like you're using ChatGPT or something, and you like give ChatGPT a request. Software observability would be like, did my OpenAI API call, like, was it successful, right? Did I get like a 200 status code? Or were my OpenAI servers, like, were the servers up and running? Or like, were there any errors or exceptions in the code or like in the execution? Or like things like this, like checking errors or exceptions in the actual running of your software and the different components, or like servers and stuff like that, your back and your front end. And so it's kind of like answering like, did ChatGPT actually deliver a response to the user? And what are maybe some issues that might have went wrong in there? But AI observability is kind of like, was that response that was delivered to the user, or was that a correct response, right? And so you're looking more at things like the tool calls that your LLMs might have made. You're looking into like, was the response from the LLM, like did it match the system prompt instructions, or was it relevant to the user's query? Or if you have some RAG set up, like were the documents retrieved, were those relevant or pertinent to the user's question? Or if you have some like MCP integrations, like how did those go? And things like that, you have guardrails. So I guess it kind of answers like AI observability specifically is giving you insights into like the kind of AI native components of your application, kind of like the things I just mentioned.
Very nice. And Sam, what do you think?
So I think like the term observability, and I don't think this is very controversial, but like, masks a wide variety of like very different sub-concepts that are being grouped under it, right? So at the most fundamental level, you have traces and you have evals. And so, traces are this like, you need a columnar DB to store like gigabytes or terabytes like at scale of sort of like application data that's like structured in a very particular way in a deeply nested format that like you can kind of like search over. It's very easy to set up tracing. Like it's usually like a line or two of code if you're using an observability provider and a framework that are well integrated together. Then like evals are these sort of like statistical tests that you can run on your agents or LLM-driven applications to sort of like see how they're performing, and require a decent bit of like just like sense of like sense for statistics and like thinking through the problem and should I be unit testing this, or do I want like more of an end-to-end integration type testing approach? And you can set up tracing in 15 minutes. It's going to take you a day or two to get like some half decent evals up and running that you feel like pretty confident about. And then there's a whole set of other things like annotations and data sets and experiments and sort of like prompt CMS type stuff that is kind of shipping in various platforms. So I think like it's a term because we're all vendors with pieces of software to kind of describe functionality, but I do think it's important that like there are very distinct subcategories of things being grouped under this like one big overarching phrase.
Yeah, I think that's a really great point. I'll say, if you saw this event a couple days ago, we were originally going to have a fourth panel speaker, Matt Wing from MCP Jam, which is really focused, or what I know them for, is they really help zoom into certain parts of an AI application. So if your MCP auth flow, for example, is failing, they can provide visualization tools that make it really easy to debug, oh, this request is failing, but where exactly exactly is it failing in this handshake of this kind of flow? So I think all of us have spoken to sort of the different levels of abstraction that are useful, whether that's at a particular request or something higher level or tied to a business goal that's more on the evals kind of side. So I know this is kind of a loaded question. If you had to choose which layer or size of what unit do you think is the most important in terms of AI observability? And whoever wants to take the...
So I'm going to take the easy answer and say that all units are important, but I think especially at Arize, we have like 3 sort of main units for observability. So there's like a span, which is like one, like let's say for an agent, right? It would be like one tool call or one LLM call or like one sort of RAG retrieval, right? So like if you're thinking about like Cursor, like a span would essentially be data on like one sort of read file operation, right? Or one edit file operation. And like observability would kind of give you data on like what parameters was that read file tool sort of called with, what was like, let's say it read a file, did it read the correct file, or did it read the entire file, did it only read like a truncated portion of the file, right? And so that level of observability lets you like put a microscope at like one individual operation. And then there's like sort of traces, which is a collection of spans within one request. So if you ask Cursor to like add a feature, there's going to be multiple spans, right? It's going to read a file, which will be a tool span, and then it'll make an LLM span to write some new code, and then another tool span to update the file with the new code, then maybe another LLM span to generate a test, and then a tool span to write a terminal command, or like to call like to basically run the test in your terminal, and then maybe like a final LLM span to tell the user, okay, the test worked, here's the edits I made, here are the changes, right? And so all of that is kind of put into one trace, so like one request. And then that tells you, that gives you answers questions like, was the user satisfied overall? Let's say my read file tool failed. Was the agent able to figure out that that tool failed? Or did it think that, that it read the correct file, and then did it end up actually making some wrong edits? So that answers different questions. And then there's also even higher than a trace is like a session, which is multiple traces. So like let's say I use Cursor like 10 times today on like my code base, like that's going to be 10 traces that fit into like one user session. And so if you have data on all those traces within one session, you can answer questions like, like was the user satisfied with their usage of Cursor today? Or like, let's say like, if I'm using Cursor and in my like second request to Cursor, I give it some information. In like the 9th or the 10th request, was it able to remember what I said in the second one properly, and was it able to answer that? And so I think like I know it's the easy answer out, but I really do think that like all sort of, at least in terms of AI observability, like these 3 units are all really important because they answer different questions.
That's definitely the technical answer. I would give a slightly different answer in that I think the fundamental unit of AI is the single chat turn. So and the important thing about a chat turn, right, when you're sending a message with some context to your LLM provider, it contains both something you control, right? You control all the context you put in there, your systems, your tool calls, your user messages, and something you fundamentally don't control, right, which is your LLM provider. I assume not many people here are doing custom inference, though maybe some of you are. And that also is going to be, in most cases, your least reliable API that you control. So if there's one thing you like want to like look at very closely and instrument a lot, it's those like single chat turns. And I was going to end up as spans and traces and stuff, but like make sure that you're thinking about each of those like as separate events as well.
What do you think about non-chat applications?
So chat is the API we have landed on for LLMs, right? I actually was here in the days when we were just doing completions, if anyone remembers those old APIs. But for the most part, everyone across all different LLM providers are all standardizing on like chats are what you do, even if like the actual thing is a workflow or some master orchestration where like the user experience is not chat at all. Under the hood at some point, you're going to be creating chat completion responses for basically any LLM API today.
I see. Sam?
Yeah, to kind of second that, I mean, we were, for example, like just at the bar with the Gamma team the other last night, and they were talking about how if you're not familiar, Gamma is sort of think about it as like a Google Slides PowerPoint type thing, but with AI built in, and they've gotten a lot of users very quickly. They're sort of replacing they had sort of built AI into their their slide software at like several different places in the UI, and finally like they kind of realized that like it was like it was hard to maintain context across a bunch of different user actions, and so they're sort of in the process of moving their interface from like, hey, let me do 5 different AI buttons to like let's have like one unified chat interface that like controls all of the different actions. I'm using that as an example because I think it's a great real world use case of like what Morgante just said. Chat is we have settled on chat as the dominant interface by which people prefer to interact with agents because we can build these abstractions on top of it. We can remember past actions. We can call tools. Those tools could do a wide variety of things within an application, et cetera. So for better or worse, this is where we're going.
Cool. Yeah, I think that's super interesting because I do agree with Morgante. He said that the LLM is often the most unreliable part of a stack in an AI application. And so I think it's really interesting. And so I used to be a software engineer myself. I was on low-level distributed systems kinds of things for a while. And I always has found it fascinating that it is possible to build totally reliable systems like, say, TCP on top of things that are unreliable. And so I do think everything that we've talked about so far today is that you need to be able to monitor these things to find the issues so that you can construct reliable systems from even parts that are not very reliable themselves. So I want to turn this question around a little bit. I used to be in the sort of SRE developer infrastructure kind of space. And I think something that is not natural if you're not from that space is the fact that oftentimes things like an average, like the average response time, is not very useful. That if you're only looking at the average response time of a system, you're actually going to have really horrible, awful behavior because of tail latencies. And so it's very common to use, like, say, a P99 of request time rather than an average. So I think in the same ways, today I think we're still in earlier days of AI observability. So I'm looking for you guys' hot takes here. What is something that people think is useful but actually isn't? Sam?
I think just for first comment, like I love the TCP analogy, and I'm definitely going to use that in the future. I think that's a great analogy. I'm going to go with RAG here. The RAG is dead hot takes are obviously a little bit spicy, but RAG is a lot of what people talk about when they talk about RAG is a 2023 era of AI applications where we did some really cool stuff with embedding semantic representations of text and being able to do better search over it. But now it turns out that, if we, go and, it's actually interesting to watch, for example, like Cursor and we're using sort of like file search and then iterating quickly, asking the user for feedback. And that actually tends to be agentic search with sort of like human in the loop tends to be often a better, faster way of coming to a more correct answer with a better user experience, with like less technical complexity of having to set up a whole ETL pipeline beforehand. Start with agentic search and go from there.
I think the best answer I have for you is not something that people think they need, but they actually don't need, or probably something that people think they don't need, but they actually do, which I think is Evals. Like a few months ago, Sean Wang or Swix made this like really hot Twitter post about how you don't need evals and that evals are overrated and that you shouldn't view evals as blockers to like shipping sort of agents or shipping code. my rebuttal to that is that I don't think evals should be blockers for you. Like, they shouldn't be viewed as something blocking you from shipping code into or shipping agents. It should be something that helps you see the different edge cases for your agent, or sort of seeing like the different functionalities or different types of queries your agent can have, and analyzing failure points, and like seeing like finding room for improvement. And so it's kind of like if you like write tests for your software, like you can say that like writing tests is like blocking you from shipping it, but in reality it's kind of helping you figure out where you need to improve. And also kind of the biggest piece of evidence that like Swix had was that like Claude Code, like they didn't use evals, right? Anthropic didn't use evals in writing Claude Code. They just shipped it because they felt like it was good, I guess. And I guess like my rebuttal to that is that so I think like back in I'd say like July or August, some people started to complain that Claude Code wasn't like working too well, and it kind of lingered for like a month or two. It started to gain a lot more traction. People were realizing that Claude Code wasn't working too well, and it was like a lot slower. And then Claude Code, like they weren't really doing anything about it, Anthropic. And then they put out this blog post in late September where they were like, okay, yeah, we fixed the bug. It was something to do with our context window routing. And then they had a section in there where they were like, oh, this is why it took so long to actually figure out this bug. And they said it was because they had noisy evaluations. And so they said it was because their evals that they built were like not that strong. They weren't that telling. Also that sometimes instead of doing evals, they would do this like spot checking where they just like let a few engineers like use Claude Code, and then like for some time, and then if it like worked well, they were like, okay, let's ship it. So I think evals are important for two reasons, mainly because you know, they like just the mindset around them shouldn't be like a blocker. They should be helping you figure out how to improve your agent, and kind of like this like sort of gives you kind of like a feedback loop. And the second is that there's like some of the biggest or most popular, most used agents out there like Claude Code, like face some big issues when they didn't use evals or when they didn't write good evals.
Cool. I would take kind of the opposite view. In particular, I think evals are actually really helpful. What is useless is generic evaluators. If you go to like AI observability vendors, I won't name any of them, but some of them will offer things that will tell you like, oh, how helpful was your AI, or how concise was it, or how friendly, and there's like sort of these generic evaluations that they'll run on prompts. I think these are completely useless. They're just telling you like mostly how powerful is your base model. And the other thing is, even for the Claude Code example, the reason that Claude Code doesn't really need to run evals is because the same part of the organization, the model training part of Anthropic, is definitely running evals, and they're looking at SWE-bench, they're looking at these all the time. And for the most part, if you're going to do evals, they need to be very specific to your domain, not something that model trainers are already looking at. So anything generic like helpfulness, anything like conciseness, precision, also domains like software, for example, like all of the big labs do lots of evaluations themselves during training on how well if it behaves in there. And if you talk to like people building coding agents, lots of them don't do evals. I also talked to some people who are doing like legal stuff and like very hyper specific medical stuff that like is not in the base models, and they are obsessed about evals because the base models don't know it and they won't be able to evaluate it until they actually run their specialized knowledge. So make sure that evals that you write are ones that only you could write. They're useless if like another organization or another company could write the exact same eval.
Nice. That's super interesting. I think we have some time right now. We can take some questions from the audience if anyone has one.
No questions.
Oh, back.
I'll run it. So I'm curious about the patterns that you guys see. Like classically, it looks like you guys are talking about like APM type solutions. So like within an AI type pipeline, like where would you stick that kind of APM type reporting that would be different from a classic type web app?
Oh, could you like what's the difference you're trying to highlight exactly? Like,
yeah. So like if you've got New Relic, if you've got like a New Relic that you're paying for or whatever for like a classic web app, like you have their APM stuff in your app, and you look at the traces, whatever, APM reports, right? New Relic reports. I guess how would you code that differently for AI stuff that would kind of be different from classic deployments?
I mean, I think the thing you're sort of like, if anyone's like used New Relic or Datadog, like you sort of figure out, they help you figure out like what is the latency here, what is like the response time, what's P99 on this. Honeycomb does this very well. These are questions about system behavior and uptime and user request latency. They don't have a lot to say about sort of accuracy and correctness, which are the typically hard parts of building agentic applications.
Okay, so just different data.
Yeah, I'd say it's specific to like tool calls, what are the parameters for the tool calls? What is the context received? When that context was given to an LLM from whatever tool you call it, was that the right context? Is it relevant to the user's question? Did it help the LLM respond to the question, or did the LLM follow the system prompt instructions? Or let's say you're doing some RAG, are those documents retrieved? Are those relevant to the user's question? So yeah, I'd say it's like a different set of data you're kind of collecting.
So then would you want both tools? Sorry.
Yeah.
Yeah.
Yeah, I mean, Honeycomb is a more traditional observability vendor. So we would say you should just install Honeycomb and you have all of this, right? It does spans and traces that include just looking at your database and normal stuff like that, all the way up to your actual LM requests and your messages there. I would say that one of the big differences is traditionally data volumes are really important to pare down observability. Everyone's heard of the $80 million Datadog bill, right? It's something that people spend a lot of time making sure they're not sending too much data to their observability vendor. LMs kind of flip that in that every request is expensive on its own, right? You don't get cheap inference. Nobody has to release cheap inference out there. So there's very, very few cases where the actual underlying LLM request would be more expensive or would be cheaper than storing it. So in most cases, anything that's touching your language model, you're going to want to use much less sampling on language with traditional observability. You want to capture much more of the request data, all that together, that you're going to sort of tune your configuration quite differently for that.
Cool. Yeah, great question. Actually, you've pulled a question out of my later plan, but I feel like just now it seems like all three of you have sort of internalized the language of open telemetry, that there are spans, there are traces, and so on. And I was working on a similar thing a few years ago, back when it was open tracing. And so I think we're at a similar stage right now. We're in the early days of sort of AI observability. I'm not sure we really have aligned on kinds of terminology or best practices like we have for traditional web apps. So what do you think is next for this field? What's a fundamental primitive that you think is important in this area?
At least this is something that I kind of work on a lot, every day. So I guess, but for me, I think what's missing is it's not exactly observability, but it's improvement based on your observability. You can have all these kind of, I guess, all your traces, all your data on how your agents are performing, but kind of closing that loop of improving your agent based on that data. I think I said this before, but it's pretty manual still. At Arize, we do something called prompt learning, which is optimizing your prompts based on some of your traces or your data of how your prompts perform. But that's just one component of agents, right? Prompts are just one component. You have which LLM should I use? What are the invocation parameters? Or what is the architecture, right? What are your tool calls? If you're doing some RAG, or what order your tool call should be, what path your agent should take. So kind of doing that, sort of automatically optimizing that based on your sort of traces and your evals, which is really cool because that's kind of what you were talking about with random labs. And that one is it makes a lot of sense to me because it's a coding agent, right? So a coding agent can optimize a coding agent because coding agent is code, right? But how is that going to work for something that's not a coding agent? And what's going to be that actual optimization step? So I think that's pretty interesting. I think something that comes to my head right now is expose your traces through MCP to cursor, and then you're okay, or any coding agent, right? And so improve my application, whatever it is, based on that. But still, I think closing that loop, I think, is something that's pretty interesting to me.
Yeah, you should definitely use the Honeycomb MCP server if you want to do that. Now, you were asking like fundamental things. We've all been talking like spans, and I think spans are like really clear in that like, every message and every tool call can be a span, and like every database call within that. I actually think the more high-level primitives we haven't agreed on like the right nouns for. In particular, like if a trace, is a trace like a single message within a thread, or is a trace like an entire conversation, right? And like you could, there's really good arguments for both, right? You could say like a trace is a conversation because it has like all these different requests that are part of it, and that's what traces were originally built for, is to allow you to have combined different events from different services together. The problem is almost every vendor out there will break if you try to have a trace that lasts multiple days. Like they assume these traces are pretty fast, but a conversation can easily last multiple days. I have conversations I've had with Claude for weeks where I just keep adding things and showing up with ideas to it. So I think we really do need some sort of new concept of a conversation or like a long-running session within observability that doesn't really exist today. And of course, didn't really need to exist when you just had like stateless database calls, but it very much needs to exist when you have a second entity in the AI that you're interacting with.
Yeah, and to round us out, I mean, if we sort of like go back to 2018 and 2019, like the reason that OTel sort of took off was that people felt like very locked into Datadog. And there, like the sort of like a couple of the smaller vendors like Honeycomb basically pushed a standard that would kind of make it easier for teams to instrument in a way that they could port across observability vendors, right? And it was sort of like the alliance of the small against the big. So like I actually think we're in a similar challenge. Like we started with OTel tracing sort of by default for Mastra. We still have that. But for the sort of leading vendors, we've actually customized our tracing in a number of ways, having to do with how messages are attached and like doing it in a specific way that like, displays better in their UI, and like attaching token counts in a certain way, so on and so forth, that are not or like very vendor specific. And obviously, like, an engineer on our team has been working on this for, he's probably spent 2 months on this at this point. And like, this is an effort we're doing because we're sort of a framework that integrates with a lot of different observability providers. But like, this is probably not the kind of effort you want to do as just a normal user. It's just a lot of work to do. But the OTel spec is not sort of robust or updated for AI enough, or specific enough and the vendor implementations are different enough to like create significant challenges without, right now.
So quick Arize shout out. So we have OTel specifically for AI called Open Inference, so check that out. We also have Mastra tracing, so you could check that out too. And also, I think you were talking about collecting traces, like are sort of like multiple, like within a conversation you have multiple sort of traces, I guess. So at Arize we call those sessions, which I think you mentioned that word as well. And you can do like session evals and stuff like that. So yeah, I definitely think like there's a lot of conversations to be had between traces and sessions and what that data sort of means for you.
Nice. Cool. Let's take another audience question, and I'll say, I think I saw you earlier. I'll say for the panelists here, I'll give you a challenge. Try not to self-promote in the answer.
Observability and human debugging in DeepRL was a lot of fun. You had these agents playing video games or robots falling over, so it would be very humanly pleasant to watch. Now you have these very long agent traces, like a lot of text or code, quite boring to watch. Like, what are innovative approaches you have seen to make this logs and observability traces more human-friendly, except of throwing them into some self-improvement agent?
I mean, on a basic level, like custom UIs, right? If you're displaying an email, if you're reviewing an email, like ideally it would be formatted to look like an email. So we've seen some teams have success doing that. I mean, the second thing is you can always view whatever you're doing as a game.
one thing that I just vibe coded a tool that just shouts out interesting messages that we receive. Like we have a little LLM that just like does a daily thing that like looks in all the messages and says, oh, these 3 ones are funny or interesting. And it's amazing what users ask sometimes. So that's a way to keep it interesting, is just let the AI do the grunt work for you, and you can do the more fun parts of just looking at the funny messages.
Cool. I'll chime in here, though I'm not an expert in this field. I think that today's tooling is really lacking in like multimodal interpretation, right? I really need to be able to, when something fails, to have something scream at me, or to deliver like a small electric shock to my watch or something. That would really motivate me to fix my problems. Cool. Another audience question.
Yeah. So obviously you saw I was using Brain Trust, which I'm sure you both want to get more people off of Brain Trust and onto other things. However, prior to using Brain Trust, I built my own observability stack from scratch because none of the tools supported any of the things that we needed. And one of the things that I have been looking for that I don't know actually really how to do, and I'm kind of curious what your guys' thoughts are, is more complex agents or multi-agent systems, et cetera, because all of these things are kind of event-based, and they're all sort of, you can almost think about them as like an actor model system, but they're not quite. They're actually just like a distributed event-based system. And you have an agent, you have multiple MCPs. Potentially, you're like us, we do multiple model calls, and we need to kind of be able to join different traces in different ways and interpret them. And I think that is an aspect of tracing. I used to work at Amazon. None of the tracing stuff that I saw there was very kind of branch oriented or non-linear. Most of it is most tracing stuff is very, very linear. And yet there's a lot of these chat paradigms that are kind of coming where you want to be able to see branching. You want to be able to see, context forking. You want to see where context is being joined, et cetera, et cetera. And none of that, I think, I have seen really. And so I'm wondering if where's the field going there?
I definitely agree. That's traditionally not done much. The truth is, the OpenTelemetry spec is a massive document that has a lot of these things covered and just are underused. So in particular, OpenTelemetry does support span links and trace links. So one thing that no self-promotion, but one thing you can do with any OTel client is implement just using the trace links, and you'll be able to look at this, look at 2 parallel traces, and I think good vendors will pick that up automatically and be able to show that sort of branching and those links between different traces and different spans. So I'd say spending some time or having Claude Code spend some time with the OTel spec is usually worthwhile if you're getting deep into observability.
Yeah, you're going to have to do some level of manual kind of granularity, tracing, It's hard to automatically create that nested space, it's something that you kind of have to manually do based on your application, which also means that you can ask Claude Code to do it for you. It's definitely a good point. In general, it's pretty linear.
Anything to add, Sam? Cool. One more audience question. Oh, so many. I think I saw Sam first.
Earlier, you guys mentioned that evals could be beneficial, but you have to be careful that you're not evaluating the model, rather you're evaluating the agent that is building off of the model. What would you say is a good or important rule of thumb to create that demarcation in your evaluation? And in the evaluation that you're using to check, the functionality of the agent that is building off of the model, what's the difference between that eval versus the typical, tests that would be used to, check that the system is working efficiently?
I would add a little nuance to that, that it's not that you shouldn't evaluate the model. You absolutely should evaluate models. Like one of the things that when I was running Grit, my coding startup, one of the first things we did every time there's a new model release was run evals against it using our harness. The important thing is that your evals are unique to you. You're not evaluating the same stuff that the model lab could have written themselves, right? And that's the rule of thumb I always use is like, if somebody else out in the world could have written the exact same evals, you probably are not writing good evals, right? They should be something that is unique to you and unique to the data that you have, right? But you still should definitely use it against new agents, and like that's why you write evals, is to be able to do every time there's a new model release to know if like, is this a good model or not, right? Is it soda or not? Is definitely an important question you want to answer from that. And then you were comparing it to unit testing and sort of general testing there. I'd say the biggest thing is like you have variables of levels of quality, right? So like in a unit test, for the most part, every testing system out there either passes or fails. And you can have some evals that are like pure pass fail, but much more evals you want to be like, what percentage accuracy is this? How close is it to the golden truth? Is it a slight variation or is it like completely off? You want to have a lot more gray area, because there's basically no eval that you're going to write today that any model gets 100% right, and there's going to be hopefully no model gets 0%. So you want to have a lot of more room for that gray area between them.
Yeah, to kind of tag team along there, you're going to want to think from the perspective of your organization, like what does success look like? So, for example, there's an insurance company that was using an agent to kind of like process sort of review approvals and like, hey, did this approval that the agent did sort of match the policy and all of the kind of like the data that we had on the specific incident, and like they decided that because they're an insurance company, that their metric was they want to reduce the rate of sort of like false approvals. They could have chosen that the metric that they wanted to optimize was reduce the rate of false declines, right? They obviously chose the other way around, and I like it's a little bit of a not very fun example because it's an insurance company. But I do think that like from an organizational perspective, right, like not just like you have to think about what does success for this agent look like, and then your everything, your evals, your metrics, everything should be like targeted around that.
Cool. Yeah, super great. And I think that's a great reminder that like eval is an evaluation, and that as part of that there is a value judgment that this is the thing that is important, and consequently there are other things that are not important. And I think that's always it's something that's easy to get lost as you're deep in the technical weeds, to forget that actually I have a choice to decide, is this outcome that I'm optimizing for actually what I want? So cool. We're going to wrap this panel up with a quick lightning round of questions. So try to keep it to one sentence or less. We'll just go down the line and I'll keep going. What is your preferred foundational model at the moment?
I mean, we're all playing around with the new Opus right now. It's pretty awesome.
Yeah, Opus for sure. Opus is insane.
I'm using a new one that's yet to be released, but I've been having a lot of fun with it.
Wow, way to flex on us. What's your favorite AI tool besides the ones your company offers?
I mean, we love all of our observability vendor partners equally.
I'd say just Cloud Code. I love using Cloud Code for sure.
I would probably also say Cloud Code is my go-to.
What in 4 words or less, what's something you wish we had talked about more just now that people in the audience should find you to talk about?
using observability to automatically sort of like self-improve and fix bugs. We talked about it, but I don't think we talked about it enough.
Well, way more than 4.
Writing good evals.
I think long context is something that even for observability is really hard, and we should do more.
Cool. And the last one, as the title is, for 2026 and beyond, what's your one prediction for the future of AI observability?
People will get better at writing evals.
Okay, that's like kind of what I was gonna say too. So now I'm, I don't know. I mean, maybe just like an easier way to trace like any framework, like less barriers to entry for tracing a framework in the first place.
Models will evaluate themselves a lot more. I think there's going to be way more work for self-reference and out of the box. So if you do nothing, they'll do it.
All right, well, there's our panel. Can we get a hand for all of our panelists?